Hi, in today's episode we are switching from electrics to electronics. We are going to build our controller for the Powerwall, and for this we have to use a so-called microcontroller. And what is a microcontroller? A microcontroller is essentially a chip on a board with an interface to interact with the outside world. There's many types of microcontrollers, and I decided to use the Arduino Mega for our project because the Arduino Mega has a lot of pins, input-output pins we can use. It's still too many available pins, but it's a good investment. We can always maybe try to expand with different modules. As you saw me the last few weeks, I was experimenting and testing with a kind of prototype setup. And the first we will do is now we will take this apart. I printed out my schematics and a list of pins, made some photos from my setup, and let's take this apart. Okay, I have taken apart the prototype. And the idea is to make this now a more permanent solution. And I will show you what we have, what the modules are we are using, and how we will build this into a nice controller. First of all, I want to show you, this is the Arduino Mega. This is the core, the heart of our controller, the microcontroller itself, and this is the pins we can use to interface with this device. So the plan is I bought this enclosure here, the box, and the final controller will sit here inside of this box. And we can use these points to put cables through it and connect to the other devices in the Powerwall. What we need, of course, is a PCB, because now we will solder everything instead of just connecting with jumper cables. And what I bought is a prototype PCB. This is basically the same thing like this breadboard, just as a PCB. You can see the vertical and horizontal traces here, and every vertical has 5 points to be used, similar to the breadboard. And this horizontal ones we can use VCC and the ground. So the idea is now to use this kind of headers, the male and the female, and on these headers we can then just plug in our modules. So in case that the modules fail, something breaks down sometime, then we just can take it off and remove brand new one. But here you already might see some first problem. The Arduino has horizontal pins, but here also a vertical for the digital pins. And we can basically only connect horizontally on this board. So that's why the first thing I have to do, I have to cut out a place here on the PCB, which will then be here in this area of the Arduino Mega, and we can then connect with jumper cables to the other side and solder there for make different connections where we need it to the modules. Okay, so I will do this now check where I need to make a cutout, and then we will use the Dremel tool and cut out this area. Okay, you see I made the cutout now in the PCB, so we can access the digital pins, these all digital pins from the back side, and we will then use jumper cables like this to connect this to any of these vertical lines here, and from there we can then continue to make a circuit. Right, so that's the place where the Mega will sit, and if you look, it's kind of centered here inside the box, and we have a lot of space, plenty of space now to place all these other modules we need for the build. I will now solder these headers so that this is already holding firm, and then I will show you what all components we need for our build. Just made a few spots, so we can now take the Mega off the board and put it away. Right, this is the first pins, and now let's show you what all we have here. So the microcontroller, and of course the display. This is a LCD display with a green screen, and this is 20 characters in 4 rows, and it has the serial module, so we are not using parallel pins, we are using just the serial communication port of the Arduino. Next I have a rotary encoder switch. So this is a digital switch. It is just checking if you turn, and there's also a switch here if you press. So this switch will be used for programming. Then the other switch, this is a physical 12-way switch. So the difference with this switch, we will have physical signals, real signals, depending on the switch position. This will be the mode selector switch. Then this is the DS3231 real-time clock. The DHT11 temperature and humidity sensor. This is a light sensor. Then 3 of these. This is MOSFET modules. This will switch the LEDs. The LED indicators are 12 volts. So we only have 5 volts on the Arduino, so we will use these modules here to switch 12 volts for the LEDs. Then this one is the Max 485. This is the Modbus module. And then this one is a module with 4 relays. So 2 relays for 2 chargers, 1 relay for the inverter, and 1 will be here to switch a fan. Then just some small components, switch, connector for the power supply, then other connectors. Then we have jumper cables, a ribbon cable, other cables with connectors. This one will be used for modules like the LCD screen and everything what is basically installed on the front plate, because here we will put the LCD screen and a rotary switch, mode selector switch and encoder switch. And if you take this off, you of course want to disconnect it somehow. Yeah, then we have other cables. We will need some resistors. Then this one is the jumper cables for making connections here on the prototype board. And some spacers. I have one module missing, that is the analog digital converter, the ADS1115. Initially we will use the analog in pin to measure the voltage of the battery, but as soon as I am receiving the analog digital converter, which is much more sensitive than this one on the Arduino, we will then switch to that one. Each module we will use these female headers now on the empty spaces of the PCB, and then some modules can then be directly plugged in on these female headers, and then we can already make some fine actions for those modules on the PCB. Okay, so let's go ahead a little bit and I show you some results later. Okay, right, the first things are done. I made some 5-volt and ground connections to these long VCC and ground lines here, and then I put the real-time clock already. I've put them very close to the SDA and SCL pins. There will be 3 modules using the SDA and SCL, the serial bus there. One is the real-time clock, the other one is LCD screen, and the analog digital converter. We will also use that one. That's why we have here still space to connect them. So, just simple. The very short jumpers, I'm just using wires from resistors without any insulation on them. Okay, I will continue with maybe 2 other modules and then show you again what is going on. We are a little bit further in the build. What did I do? I made here 3 female connections for these MOSFET modules, while the middle one, as you can see here, up signal, then the VCC and ground. The VCC is not used because for the MOSFET you only need a signal and it must be grounded. So I removed the second pin here on that connector, but it doesn't matter anyway. And the last one is here the voltage divider, and this is the connector for the battery voltage. So the battery voltage, this is ground, comes in here. The plus is divided over the 20K resistor first, and from that spot we are taking our analog signal to the analog pin A0 for the time, but this will be replaced by the analog digital converter ADS1115 later. After the 20K resistor, the second part of the divider is then 680K and the 1K resistor in series, and then they're going to ground. Right, next what I will do is actually now, alright, the last thing I can put on the PCB is the Max 485 module. So I will find a nice place for this one, and then actually all other things are put somewhere outside of the PCB. Okay, I continue and then I'll let you see it later again. Connection for the Max 485 is done. You see the two female headers. And just to remind you, you have the 4 pins here. DI, that one is connected to the RX. RO is connected to the TX, and the DE and RE, they are connected together to one with the jumper, and then they are going to the digital pin. It's like a switch. And now you can see first time, after I put this together here, you see first time how it works. We get one jumper and put it into the digital pins from the back side, and then we just solder it from that side where it belongs. Okay, now comes a big item. This will be the mode selector switch, and for the mode selector switch we will use the middle pin. Will go to VCC 5 volts, and then when you switch the switch, the 5 volts will be passed on one of the pins to one digital pin. So we need 12 digital pins for this switch. But the other ones, the 11 other ones which are not switched, they need to be pulled down to ground. So now we have to add 12 pull down resistors on the board and connect this one then by a ribbon cable. The ribbon cable I have here, so we need 13 leads for this switch. I have finished now the ribbon cable on the PCB. You can see we have 12 pull down resistors, each is 10 kilo ohms, and the red lead from the ribbon cable goes to 5 volts VCC. On the other side we have our digital pins from the Arduino Mega and connecting to each of one of those verticals. Okay, next step is now the ribbon cable on this side. We will connect the red one on the center pin, and the other ones, luckily the switch is numbered, so we can connect from 1 to 12. The other ones in the same order like we have it here. Switch is finished. I connected all the wires of the ribbon cable and put a little bit of heat shrink there, and so we have now 12 positions to select, and each of the positions will be a different mode on the Powerwall. Yeah, until now everything looks pretty good. For the next part I'm going to connect these items which have a special cable and can be then disconnected with this kind of plugs. So this will be now the display and the rotary encoder, the temperature sensor, and then finally comes the relay module, and this will be already just put inside the box next to the other board. So I think now I'm just short before putting everything into the box. What did I do? So I now put all these last connectors, cables, wires which will basically come into the lid of the box. So these are connectors, so once I open it I can then take it off. It's just a relay module which will be just added like this extra to next to the PCB of the controller. Then I put the cables on the LED indicators. Here the cable with the plug for the rotary encoder. Yeah, this is actually now everything done for what I have here. The temperature controller, I will make some cutout and let the sensor just look out of the box so that the air inside the cabinet can pass over the sensor, and then we can read the temperature inside the cabinet. Okay, so I'm now ready with the spacers and with the drill, and we'll start to make some holes and install these PCBs and all these switches into the box. Okay, I see you in a bit. Okay, look at this now. Okay, I have the main PCB with the Arduino is in place with all the modules on it. The relay module, they are all on spacers because we have the wires underneath. And for the temperature sensor I decided now like this because it was kind of not possible to, because of the housing here is very thick, to bring the sensor out by a cutout. So I just took one of these rubber gaskets here, outlets for the cables, and just made a slit there and just put the sensor through it. So it's kind of even watertight. Well, there will be no rain anywhere, something on this, but the sensor is outside. So this is the plug for the LED screen and for the encoder. The switch we have to put somewhere in this area because it's quite deep. The LCD screen, I think we can actually put it wherever we want because we have some extra space here inside this one. Yeah. So this is the next. I will make some holes here and the cutout for the screen, and then actually we could use a 12 volts power supply and see if it works, because the software is already on it. It should at least show something. Okay, so give me another maybe 15-20 minutes and then the project for today is finished. Okay, the build is finished so far. This is the inside of the lid. We have the mode selector switch, LEDs, and the rotary encoder switch, and the LCD display. I turn this over. Looks pretty neat. Mode selector switch. I have the cap here. LEDs, green, yellow and red for the different modes of operation: charging, discharging, operation. Here will be the rotary encoder, but this one will be exchanged. Already getting a new one. I bought this one in Thailand, and you see it doesn't have a thread, so how would you fit this? It's kind of stupid. And the LCD display. So the only thing missing now is plugging this together and giving it some power, and then it should work. I will probably do this tomorrow because now it's already kind of late. So I would say the video from the build of the controller board is finished. It was kind of fun, and yeah, it still took much longer than actually I thought it would, but that's mostly the case with projects like this. I hope you found it interesting. Please like, subscribe, and there will be more videos coming. The next video will be about making here the final connections and power supply, and then we will power it up and see if it works. So thank you again, and see you next time.